Question number 7 on our 1033 Test 3 review gives me a position function, which basically tells you where an object is located at any given time after it's been propelled upward. So what we're going to do is let's look at this position function. Alright, we have the function h, or another way to say it, h of t, is equal to the opposite of 16 squared plus 112t. T represents time in seconds, and that's how long the object's been in flight since it's been released, and h is the height of the object above the ground. So the first question says find the height of the object at the end of 1 second. Well, 1 second is time. So what they want us to do is to come to this formula and put a 1 in for t. So h would be equal to the opposite of 16 times 1 squared plus 112 times 1. This is equal to, okay, 1 squared is 1. That multiplied by negative 16 is negative 16. Plus 112 times 1 is 112. And remember, in 1033, you're always allowed to use, your calculator. So when I do this, I can either do this by hand, or I can do this using a calculator. And what I get for my answer, negative 16 plus 112 is 96. And of course, we should use the correct units. That would be 96 feet. So at the end of 1 second, the object is 96 feet high. Find the height of the object at the end of 2.5 seconds. Well, again, 2.5 is time. So I go to my formula and I plug in a 2.5 for t. H is equal to the opposite of 16 quantity, 2.5 squared. Whenever I have my students evaluate a polynomial function, I like for them to put what they're plugging into the function in what I call little safety nets. So I have plus 112 times 2.5. Okay, this is definitely going to be calculator time for me. I don't feel like doing all that by hand. So I'm going to pull out my graphing calculator. Of course, in 1033, you're not required to have that, but I'm going to use mine. We're going to have, let's see, we're going to have the opposite of 16, parens, 2.5 squared. Okay, these graphing calculators are wonderful. Plus 112 parens, 2.5, close parens and hit enter. And my answer is 180. So h is equal to 180 feet. Okay, so at the end of 2.5 seconds, my object is 180 feet in the air. Now my last question asks, when the object hits the ground at what time, or when does the object hit the ground? Now, of course, what I want you to think about is, when the object hits the ground, what you're looking for is time, okay? How long does it take the object to return to the earth? How long does it take the object to hit the ground? So you're looking for t, okay? We don't know t, but we do know h. H is equal to 0. And of course, the reason we know that h is 0 is because if the object is on the ground, height is equal to 0. It's 0 feet above the ground. So I take my formula, h equals negative 16t squared plus 112t. That is called my position function, and I set h to 0. 0 is equal to the opposite of 16t squared plus 112 times t. And what we now have is an equation, and in fact it's called a quadratic equation. It's degree 2. I teach my students when they're working with a quadratic equation to put it in standard form. Standard form means that one side is equal to 0, the other side is in descending power order, but one additional thing that I like them to do for standard form is I like the leading coefficient to be positive. Well, obviously negative 16 is not positive. But if I multiply the entire equation through by a negative 1, 0 times negative 1 is still 0. When I multiply each of these by negative 1, the signs reverse. And I think it's a good habit in algebra when you're working with a quadratic equation to put it in standard form. One side is 0, one side is descending power order, and the leading coefficient, meaning the number in front of the squared term, is positive. We now factor, and let's see, if I look at this expression, you may need to play with the calculator a little bit, but I think 16 comes out of 112 7 times. So my GCF is 16t. And in parentheses, I'm left with t minus 7. If two factors are multiplied to give me 0, then either the first factor is 0 or the second factor is 0. In this first case, I divide both sides by 16, and one answer, 0 divided by 16 is 0. But to be honest, that's not really my most exciting answer. I really kind of wanted to know when the object was going to return to the ground. And that would be this answer. T is equal to 7. So technically there are two answers. When was the object on the ground at time 0 and at time 7? But this is actually the significant answer, 7 seconds, because the question wants to know when the object hits the ground. So that's basically returning to the earth. So my answer here is 7 seconds. Thank you.